that we can share this with you. You can study later on too. We are gonna go to question number 11, and from there we go all the way to question number 24. That's the last question on this practice exam. Again, the first 10 questions were discussed in our previous meeting, and we'll share with you the link to that. Besides, we'll share with you the link to what I'm going over today, which is question 11, all the way to the last question, question 24. All right, you see my shared screen, right? Still? Okay. This question is open for discussion. Let me know what you guys think as to which answer is the best approach. So as many of you indicated, the best approach to simplify this visualization is to create groups. So we group them without eliminating any data. Remember, we are not filtering, we are grouping. And that would decrease the number of music format categories. Here, as you can tell, we have way so many, so we may be able to combine some of them that are related. And that way, the visualization that we want to deliver is going to be easier to look at, and therefore the audience can gain insights from it more easily. Question number 12, change in composition of a set variable over time. Adi, you are right. So composition. Okay, what does that mean? That means we want to look at part to whole ratios too, in addition to part to part. And which one does that best? Stacked area chart. Because the other options here are either irrelevant, like histogram, or they're not good for part to whole. They are good for part to part. Only stacked here can be effective in making part to whole comparisons. Question number 13, we have a true false question, and the answer to that is false true. In addition to visualizing hierarchical categories, tree maps can visualize two quantitative variables and one categorical variable all in one chart. That's a false. Okay. Because what we are describing here is hierarchical. Then icicle charts are easier for a layperson to, yeah, we already discussed that, right? So it's false true. All right, you guys remember k-means plus and k-means, right? That was our discussion last week, and I believe this question is either a copy or very similar. Oh, it's hard to go back, but let me put this here and keep that open for discussion. All right. Tony is asking why this is wrong. Who wants to explain that? Anyone? Ade, go ahead.
Yeah, so I think tree maps can only visualize two quantitative values or with size and color. So if we want to use the color for category, then it will be one quantitative using size, and then the color we use it for category. So it's either two quantitative or one quantitative, one categorical.
I think there is a mix up too. So in the quiz, so you got that right, Ade. Let's have a round of applause for Ade. Now let's discuss this. This was in the practice exam. So what I put in there was from the quiz. So is this wrong? Is there anything wrong with this statement? Ade, what's wrong with this?
Because if we're already visualizing two quantitative variables, then we don't have space for a categorical variable. So we can, in addition to the hierarchy, we can either do two quantitative or one quantitative, one categorical.
So yeah, so it goes back to the point we made. It must have been last week. When we say hierarchy, that means we are already taking care of categories and subcategories, etc. So category becomes irrelevant. So you say we are visualizing hierarchies and one quantitative variable, two quantitative variable, one of the two. Okay. But if you say we are visualizing hierarchy and we are visualizing a category, then it becomes wrong. Okay. So, okay, another round of applause for Ade. Thank you, everyone. All right. Okay, now let's deal with question number 14. What do you guys think? Yeah, it's B. We discussed that last week. Question 15. What do you guys think? We are going to combine related members in a field. We already discussed that in an earlier question, right? So that's done by grouping. Remember, no filtering. So number 4 is irrelevant. Why? Because with filtering, you are ignoring part of the data. Let's move on to question number 16. My favorite visualization of the course. One of my favorite ones. It's a true-false question. What do you guys think? Question 16. Some people say, oh, we have actually all of the answers. So that makes it more interesting. It's better to make the color of each music format here transparent. That's a false, because these have been placed on top of each other. So they do not overlap. So when they say 8-track, that's this small amount that we have here. It doesn't mean that it's from here all the way to here. So these guys don't overlap. As such, we don't need to have transparent colors in this specific chart. Sales of our categories share the same baseline. That's a false too, right? Are we good? So you agree with me this is false, false?
So on the left side, it's value in dollars and billions, and it's over a timeline.
Yes.
So for 8-track, I mean, at the same year, it's both at 10 billion and below, above 10 billion and below 10 billion on the same year.
Yeah, so 8-track pretty much you can think of it constant here. The reason it changes is the variation in vinyl. Because the reference for plotting this is this. Am I making sense? The reference is not this, the reference is this. So this is like a stacked chart. So FF, are we good? Any questions as to why this is FF? All right, I'm moving on. Association analysis in Tableau, something that you guys did a couple of times. How do we generate association analysis in Tableau? Yeah, join the data tables in a clever way with particular rules to find interesting relationships in a large data set. And this is a repeat. Question number 18. Which one is preferred? This question is not a repeat. We have had a similar one, but not exactly this one. We have 5 categories. In here, our chart consists of 2 side-by-side pie charts. Here we have a group bar chart. It's easy, right? Here we have to do back and forth. The number of categories not too small. Whereas here, everything is in one chart. Part-to-part comparisons are very easy. So this is 2. Here again, 2 pie charts next to each other. It can rarely be good. So again, this is much better. You see the trend, you see which one is going up, which one is going down. And that's done without the need to do back and forth. 2, 2, the correct answer is 2, 2. Question 19. We have 4 scenarios, and you want to see which bar chart is better for each scenario. Visualize the trend of the yearly harvest of cotton between 1985 and 2015 in the state of Alabama. That would be a line chart. Visualize the proportion of graduate students who take buses as their way of commuting to school compared to other ways of commuting. So what options do I have? So line chart between these two. Sunburst, pi. Which one makes more sense? Pi, right? So we can already choose which one is the best answer, but for the sake of learning, let's continue. Visualize the social networking user population for a few social media platforms in terms of male and female categories. Stack bar chart would be best. Gantt chart would be irrelevant. So is sunburst chart. Compare the categories-wise sales figures for popular motorbike models with 2 quantitative values. The average sales for a model and the percentage growth in the. So when you say 2 quantitative variables, you don't have many options. Okay. And in this class, we learned tree maps. Question, this is about the video lecture that I specifically designed to explain in which scenarios pie charts could be useful. We learned that the scope is not wide. Pie charts are good for between part comparisons. That's false. The one thing they do poorly is between part comparisons. Pie charts can easily distort the data. Yes, we saw an example of it in the class, right? That was the Apple event in which they showcased iPhone. Pie charts are not as space efficient as bar charts, right? Because they are circular, so the area around the circle gets wasted. Pie charts tap into human beings' instinctive ability to assess proportions. Yes, especially if it's, let's say, 25%. Our visual system is very good with detecting that. Question 21, bar chart and a histogram. This is important because bar chart and histograms, you know, if you look at it from a distance, they kind of look alike, but they have a fundamental difference, and that's their purpose. Okay. When it comes to bar charts, you have some categorical data along with quantitative values. But when it comes to histograms, you are looking at distribution of quantitative data. There is no category in your data. You are making categories out of the distribution of your data. Do I make sense? So it's their purpose that's different. So with the bar chart, your data has some categories, but with histograms, your data is not categorical, nor does it have any categories. You have a bunch of numbers, and then you want to see the distribution of those numbers. Okay. For example, it's a normal distribution, or no, it's like an increasing distribution with no normal pattern in it. So that's number 4. Question number 22. What does a histogram show? This question is basically an add-on to the previous question. Is a graph of the frequency distribution which the vertical axis represents the count of frequency and the horizontal axis represents possible range of data values. So again, you have one-dimensional data, you have a bunch of numbers. You want to see what the distribution of those numbers are. For example, if I'm saying my average is 5, it could be the case that all of my data values are 5, as a result, the average is 5, or it could be that they are distributed evenly. For example, I have a 4, I have a 5, I have a 6, therefore the average is 5. So with the histogram, we plot this distribution and we find out how distributed our data is. All right, we have this tree diagram. The value for a parent equals the value for the children. And here, no node has more than 2 children. Indicate whether the following RCKL and tree map visualization are correctly representing the hierarchical data or not. Let me make it small so that I can accommodate all the 3 visualizations. What do you guys think? So the sum of 2 children should equal the sum of the value of its parent node. And here we have that scenario, right? There is no way we cannot follow that. And here the same. For example, under 2, we have 4 and 5. And here I have 2. And in 2, I have 4 and 5. So the reason we have these spaces is just for the sake of better seeing each of the layers. It doesn't mean that here I have some other data. I hope that you were able to find that out. So both of these are correct. The categories and subcategories are correct. Also, the sum of children node is equal to the value of the parent node. So yes to both. So it's the third answer. Question number 4. Let me make this large again. K-means clustering and linear regression can be done in what pane of Tableau? And this is a repeat too. Analytics, right? Because they have to do with data analytics. They don't have to do with, just simple data. They are pretty much machine learning. And I believe that was the, oh, actually we have more questions. We have 1 more or 2 more? We have 2 more. So I originally thought it's 24 questions. In the chart below, there are 3 measurement components. Fill in the blanks in each question below using the text target value, actual value, or performance level. So which one is which? What do you guys think? So the long black horizontal line shows the actual value, this guy. So length is the pre-attentive attribute. Actual. And then the short black vertical bar, that's the target or expectation, right? The shaded area, that is performance levels. So it could be that this is great, this is good, this is average and below average, or maybe, the more the worse. This is great, this is very good, this is average and below, something like that. Tony, let me see if I'm following. Actual and target. Tony, I'm not sure if I'm following. Are there writing errors? Oh, yeah, don't worry about the auto grading. So it might be the case that, you know, it even gives you the wrong grade. But I would appreciate if my TAs look into it and see if they can fix it. But when it comes to auto grading, you know, don't worry about your grade. It may be the case that you are getting all the questions right, but for some of these fill in the blank questions, we design them as multiple choice questions, and therefore, no matter what the submission is, it gets it wrong. So it may be the case that it's case sensitive, and the way we put it in there, it's with, you know, title case, first letter capitalized, and you put it like I'm putting here, and you're not getting the score. Don't worry about that. But make sure you get the concept right. So make sure you don't mix these three up. Okay. But as we speak, my TAs are looking into it, see if it can be fixed. And if it cannot be fixed, that's not a problem. The reason we have this question is so that we can tell these three apart. All right. Let's spend a couple of minutes on this. Identify at least two problems in the pie chart that the late Steve Jobs presented at the Macworld 2008 event, 2008. That was the time iPhone came out, or at least iPhone was presented at a huge convention. I don't think that convention is in existence anymore. I think the last one was 10 years ago. If you have more information, put it in the chat. But for the sake of this question, think about it, and then I'm gonna ask for you to chip in. What's wrong with this? And it would be better if you first identify the biggest problem and then minor problems.
Can we
Tony,
say
you identified one large problem, one small problem. That's good. A round of applause for Tony. And Lynn, go ahead.
Oh, I was just gonna say, the pie chart is kind of distorted in a way that even though the 21.2, that purple chunk is bigger than the green chunk, it looks as if the green chunk is bigger because like they distorted the
Yes.
angle.
Yeah, that's the number one problem. So that's what made this story a huge story. So a round of applause for Lynn for pointing that out. So the most major problem, the most interesting problem is that this pie chart is in 3D, and it is recommended that we do not make pie charts 3D. So back in the day, a lot of visualization tools by default, they would make pie charts 3D. But that was bad practice. It would look, you know, sophisticated back, you know, 20 years ago, 10 years ago. But it would distort the data. And we see a clear example here. 19.5%, they say it's the Apple's share of the market. This number is right now more huge, but back then 19.5, and the other category was 21.2. So this is larger than this, but this is 1.5 times the size of this slice. Why? Because this is 3D, so this part is closer to us, therefore it should look bigger. So I don't know whether this was intentional or not. I think it must have been intentional, but the way this visualization gives the message is Apple is already a huge part of the market. It's like right after RIM, which was not the case. Okay. So with 3D, the problem is that the size of each slice get distorted. So you cannot fairly compare the size of each of the slices. You have to design your pie charts in 2D so that you can fairly compare the slices. So that's number one. Number two could be the fact that we have way more, we have a large number of categories for a pie chart, so we should not have used the pie chart to begin with. Another one would be it's not colorblind friendly. Back then, they knew what colors are colorblind friendly and what colors are not, but still they opted for these two colors. For example, the green, the pure green and pure red. This is hard to distinguish for someone with color vision deficiency. Another problem already pointed out, the choice of colors. You know, these colors are hard to tell apart. It's hard to see the clear boundary between this. This was already pointed out. Like we said, and I think Alan also mentioned that the number of categories is relatively big, so we do need to inevitably have some back and forth, and the back and forth is not just one time, you know, it's multiple times. Whereas if we had a bar chart, you know, everything was labeled, you know, each bar was labeled right next to it, there was no back and forth, right? So we went over 4 problems with this, 2 of them related, but the largest problem was the fact that this is a 3D pie chart. 3D pie charts are not recommended, they are bad. And in this specific example, it's a deceiving pie chart in the sense that it shows Apple's share way larger than it was. This looks like 25%, right? But it's not. It's 19.5%. And this looks much larger than purple, whereas it's not larger than that. And, you know, you can make other arguments too. Like this is not exactly half of this, whereas in reality, this is almost half of this. The size is not half of this, is more than half. Did you guys follow those problems? Yeah, market strategy. I would say this must have been intentional. All right, a round of applause for all of you, and specifically the ones who participated today and other days. All right, at this time, we want to stop recording the 2 links for today.